Section 4.5 is on graphing the sine and the cosine functions. Now on your handout, your sheet is blank here. If you want to take just a few minutes to copy down what I have here, I've selected values for x, which are all in radians, and we're going to plug those into the equation y equals the sine of x, and that's what I have here in the middle column. And then we're going to compute what the y value would be. So you can use your unit circle, or just from memory if you've learned your sine values of your multiples of pi over 4. The sine of 0 is 0. The sine of pi over 4 is the square root of 2 over 2. But just for the sake of my graph, I've changed that to a decimal and just kept one decimal place all the way down. The sine of pi over 2 is 1. The sine of 3 pi over 4 is square root of 2 over 2, or 0.7. The sine of pi is 0. The sine of 5 pi over 4 is negative 0.7. The sine of 3 pi over 2 is negative 1. And the sine of 7 pi over 4 is negative 0.7. And the sine of 2 pi is 0. Okay, so again, you may want to just take a few minutes to make sure you have these correct. And what we're going to do is actually plot the points. So the x and y coordinates that I have here. So one ordered pair would be 0, 0. Then the next one is pi over 4 and 0.7. So I'm going to plot those on my graph that I have here. Pi over 4, 0.7, you can see I have this is 1. So 0.7 would be about here. Pi over 2 is 1. And then the point 3 pi over 4, the y value is 0.7. And at pi, we see that the sine of pi is 0. 5 pi over 4 is negative 0.7. Okay, you should be seeing some type of pattern here. 3 pi over 2 is negative 1. And then 7 pi over 4 is negative 0.7. And then 2 pi is back at 0. Okay, the graph that we have here, if you can see where I've graphed my points, if I connect my points, we get the graph of the sine function, okay, or the sine wave. This would be one complete wave of the sine wave. If you notice here, we have some terminology we need to talk about. Period is the distance from the beginning of the wave to the end. One complete wave of the sine function. Kind of what that length is, or if you kind of think of it as being like the frequency, okay, how many waves would occur from 0 to 2 pi, okay, so this actually tells us what the period of the sine function is. It's just 2 pi for our parent graph of y equals the sine of x. The amplitude is sort of related to height. Okay, if I look at my range, okay, how high is this going to go? Positive 1. Okay, if I continued and graph more points, it would never go above positive 1. Okay, and then also it would never go below negative 1. So since my range is from negative 1 to positive 1 in interval notation, I would say that my altitude is 1. Okay, the altitude is always the absolute value, or the distance the difference between our maximum point and our minimum point. But because it is a distance, it's absolute value. So the amplitude is always positive. Okay, the domain for the sine function is the set of real numbers. It can be negative infinity to positive infinity if we write that in interval notation. and then your range is always going to be related to your amplitude. Okay, so again, you can kind of think of amplitude as being the height, but it's really actually where our maximum and then our minimum would occur at -1. Okay, what I want you to know and remember about the sine function is that it will pass through the origin, and it's always going to be a curve that's going to increase to the right, decrease, come back to 0. Okay, so it will pass through the origin. That's going to be a key into how you can tell the difference between the sine graph and the cosine graph.